I'm going to talk about now how we're using Nashorn here at Netflix. So I'm Matt Sun. I'm an engineer in the Partner Tools Development Group here at Netflix. What we do is we create Netflix Test Studio. It's an automation framework in the cloud that enables a certification of devices. Now, what does that mean? We present partners with a test plan, a list of test cases that need to pass on that device in order for that device to get the Netflix stamp of approval. So the way we first approached this was we provided that full list of test cases to the partner. We have a dedicated certification team that use our web UI using CRUD interfaces, talking to a MySQL backend to manually exclude tests. For example, if a device can't do 3D, then we shouldn't include 3D tests. Simple enough. Very cumbersome process, a lot of human error, and a lot of overhead. You can think about all the thousands of devices in the Netflix world, just how much process that team had to maintain. So, next generation. Can we make this a little bit more dynamic? Can we get device capabilities and more intelligently filter it automatically on the spot? So we created this simple rules file, and the team would maintain it in S3, but it would be very limited in what it could do. Sure, it could limit some capabilities, but in order for something to be truly dynamic, it just couldn't provide that. So again, that team would have to go into the UI and manually exclude some test cases. Let alone if a new feature came out, such as 4K, which is pretty recent, they would come to us, backend developers, we'd context switch, create this new rule for them, and they would implement it. So again, it's a better solution that they're able to filter and exclude off a smaller list, but again, not something truly dynamic. So we revisited this again. How can we use Nashorn? We talked about Nashorn for a while. We wanted to use it, but we weren't really sure how we could utilize Nashorn within the Netflix Test Studio. So what we did was we built our test plan script engine off of Nashorn. We imported two interfaces to our engine. One interface is to talk to our MySQL RDS instance in the backend that contains all of our test case metadata. Another interface, REST client, to talk to a server in the cloud that holds all the capabilities of a device and its business properties. We could then import all of the Java libraries that come standard and gives that certification team now full flexibility into creating exactly what it needs, a plan that's truly dynamic. So the process is tests come in, JavaScript runs automatically, test plan presented. And the way we've done this is we provided a cloud ID for that team. That team doesn't have to open up Eclipse, modify some text file, and upload it to our system. What we have is a web UI where they can not only look at syntax and validation, they can also debug stuff along the way. So in our engine, we've implemented a debugging capability that lets you get immediate feedback from the code that you're writing. So just show you guys real quick how that looks. Here's our Cloud IDE. Let's maximize this. And you'll see this is an example of one of those dynamic test plan JavaScript filters. It's a bunch of code. And to think about how much us backend developers would have to support this, you can see how much this saves time, not only on our end, but it gives them the freedom to kind of create the code and logic and Booleans that they need. More importantly, we're able to debug. So if they're writing this test plan filter and they want to see the capabilities ahead of time, we can now add this debug capability and it prints it all out to the screen. And there's other errors. If we want something to fail, and while the Java syntax checker might actually pass, when you pass it to the server, you'll get immediate feedback on, okay, this is actually wrong. So again, just stuff we put into the engine to provide this toolbox for that certification team to be able to create the code that they need. All right, so what does this really mean? We created this great test plan dynamic engine, enables test plans to be dynamically generated for each device. But what it really means is we separated the dependency between that certification team and the backend developers. They're already in talks and meetings with product managers on upcoming features. They can easily just add the rules ahead of time without needing to come to us. As developers, we're freed from a lot of context switching. A lot of us backend developers working on a lot of parallel projects at once. We're already walking a thin line on deadlines. And to have to veer off, context switch, really adds a lot of overhead. So okay, we have this great test plan script engine. How can we expand this? We've had teams come up to us and be like, this one partner consistently failing their security tests. Can you create this one custom test plan that's just filled with security tests that I can then share with that partner? So before they come to us, we manually create it for them. They can just then share it with their partner. Now they can go into our UI, create a test plan filter by themselves, and immediately share it with their partner. Another example is, say I'm a Windows mobile developer here at Netflix, and I want to see all of the security tests that maybe iOS and Android have written. I can now do that. I've now encouraged discoverability within Netflix. A lot of times, you have PS3 teams, Android teams, all having their own deadlines, and there's rarely a chance for them to kind of communicate together. This kind of breaks that barrier. And if I'm looking at Android and being like, oh, why did you make this one security test this way? I can now start that conversation. Basically, we want to prevent any reinvention of the wheel. And again, backend engineers are no longer needed. We're giving full power to each team that needs to create the test plan any which way they want. And this is just an example of how we want to move towards a world that's more dynamic and less static. So that brings us to analytics. So what are analytics? Basically, a collection of reports made up of tables, charts, and graphs, and dashboards. It tells a story of how well your product is doing, maybe a certain feature or business process. Lets you see what's going right, and more importantly, it lets you identify what's going wrong. It really does drive continual improvement. To see, maybe A/B tests, you make one change and you want to see how it's doing. So analytics are widely used across. And here's kind of the standard list of analytics dashboards. Each one basically made up of the same types of tables, charts, and graphs. But obviously, there's a huge variety, and not two are the same. So that leads us to our problem statement. A lot of software solutions out there actually come with canned analytical reports. But the problem is they assume they know what you want, right? But a lot of the times, that's not true. Other options are available. There are third-party tools like Tableau that enable you to connect different MySQL databases together, key off some things, and be able to present reports. But that's limited because you're limited to that one single data source. Companies like Netflix, we have internal analytics teams where you can request certain reports. Backend developers can then go in, create that report, and present it back to the teams that requested them. But this is a very pull model where teams that want the reports now have to wait on the backend developers. Backend developers now have to, again, context switch and work on this kind of one-off report for that one team. And the problem really boils down to the last 2 points, is everyone really has a different view of the world, right? One dashboard, one report created for one team may not meet the business requirements for another team. Another thing is everyone thinks they know what they want, right? A lot of times teams go to the backend analytics teams and they think they require one report. The backend team puts it together for them, and the team that gets it realizes, oh, actually, that's not what they want. They want something changed just a little bit. So what you end up with is kind of this Groundhog Day cycle approach. You have different teams, each with their own requirements, their own agendas. Perfectly reasonable. They give those requirements to the backend developers, usually in parallel. Now, the backend developers need to add custom REST APIs, maybe a new query parameter or a new way to process JSON. Maybe they need to inject a new parameter into logging and then add data processing methods to process that one parameter that was just added. And now when this whole thing is done, they need to do a full stack push from test to production, right? Which we all know is always a risk. Then the team presents the reports back to those original teams that wanted them, and they realize it's not exactly what they want. They want just one thing tweaked or maybe pivot on a different angle. So they come up with new requirements, pass those requirements back down to the backend developers, and so on and so forth. Right? And what you end up with is really a Frankenstein of a backend server. You have all this one-off functionality in the server code. And as a developer, you always want to design something solid from the start. But you can't design something solid from the start because you don't know what everyone wants. And you know what? You won't know what everyone wants. So what do we do here at Netflix? We created an analytics engine built off of Nashorn. It takes JavaScript and returns arbitrary JSON. Our UI framework, which allows you to send it JavaScript, can now take that JSON and dynamically create tables, charts, and graphs. In our Nashorn analytics engine, we provided interfaces to all of the data sources you may want to merge your data with. So we have an interface to our MySQL RDS backend, Cassandra or Redis, S3 file storage, services we already have in the cloud, like, for example, that one server that has all the capabilities and properties of a device, and even World Wide Web. So say there's a REST endpoint publicly out there that you actually love and want to use. You can now do that. And this really changes the way people can think about analytics. Analytics, you think about a single source, say all my data is in the Hive, then I know the report I want to generate can only come from that data in the Hive. Or my data is all in databases, so I can only create reports from data in my database. Well, this really opens the door to get rid of any limitations and let alone create those reports dynamically. So again, what does this really mean? It means backend developers are no longer needed. When teams want to create reports, when they want to change it, they can do it themselves and get immediate feedback right away. Again, backend developers, we don't need a context switch and we can focus on the projects we need to do. We added debugging capabilities, just like we did with that test plan engine you saw earlier. And what that enables is getting rid of the black box approach. Usually when you think of a backend server, you hit a REST API and you get JSON back. But you have no idea how that JSON got formed together, and you have really no visibility. So again, you get immediate feedback for your code. And this combination of the JavaScript engine and dynamic Java, as I like to call it, allows you to have full freedom. But with that freedom comes responsibility. So here at Netflix, our culture is built upon freedom and responsibility. So we added an ACL-based model where if you created these reports, if you wrote this JavaScript, you can only share with those people that you would want it to see. So external users, for example, can't have access to it. Certain partners can't have access to it. Even internal users won't have access to it unless you give them those permissions. More importantly, we wanted to secure the engine. This pretty much unlocks Pandora's box, and we wanted to do everything we could to prevent, bad stuff from happening. So we created a secure script engine that both the test plan engine and the analytics engine extend off of to prevent, JVM going down, attacks. More importantly, any modifying or deletion of sensitive data. So that's enough talk. Let's give a demo. All right, so here is our analytics tool, the UI framework that we created. And we talked earlier about allowing teams to discover tests that are out there. So here's an example. Actually, James, can you get the lights? Thank you. All right, hopefully you guys can see this. And what we've done is we've really imported a lot of functions into the engine to give teams and individuals that might not be Java or JavaScript savvy ability to create these reports. For example, if I want to discover new tests, I may not want to know all the nuances of the test case database table schema. So we provided these helper functions in order to add to the toolbox to enable each team to do whatever they need. So this example, I want to look at all the tests that are out there tagged with specific strings. Right, so I create my JavaScript, embed it in JSON, and hit my test plan script engine endpoint. So I execute this, and I get a table dynamically. I'm not telling the UI what columns there are. It just gets a JSON and renders it automatically. And you can see other applications this could be used for. Right? You have MySQL Workbench, DB Visualizer, that's a huge overhead on your system. This essentially acts like that in the cloud, very lightweight. All right, we are part of Netflix Test Studio. We enable automation and testing all over the world. So let's look at how much our product is being used. This is our test environment, so it's a lot less activity, but this will tell the story. We've implemented Juke and integrated that into our engine too. And what Juke is it turns your MySQL into an object-oriented list of Java classes. In addition, it hides any complexity of JDBC, type safety, and gives you functionality such as converting your result set into a list of map objects, for example. Again, all things to add to the toolbox to enable the teams and developers to do what they need very easily. We also have utility classes that can transform data to the way the UI needs. So any developer can just call these functions and get the data automatically. So again, we want to look at activity over the past 30 days. We want to maybe group it by result to see what's going on. And a result could be a pass, fail, maybe the test timed out, or maybe the user canceled it. So let's look at that. Here we have our JavaScript, embedding it in JSON, hitting our analytics REST endpoint. Here we go. We have now trended analysis over the past 30 days. Again, these mouse overs are all free from the UI framework that's out there. And just another example of how we can leverage Nashorn to create line series graphs dynamically. So let's give another example. Let's say we want to create a bar chart, and kind of picking back off the activity for the past 30 days, let's see which tester in particular is maybe the most active, who's been running the most tests. But hey, I only care about those results that are passed and failed. So most teams may not know Java or JavaScript, but a lot of people that want reports actually know SQL pretty well. So this enables them to just write in SQL. Again, we have the utility method to help transform that data to something the UI can render, and embed it in JSON and hit the REST endpoint. And here we go. So Peter has been the most active on our testing environment over the last 30 days. And something I want to mention is, typically in UI code, which will always have JavaScript, what happens is the JavaScript is calling a REST endpoint, getting JSON back, and then post-processing that JSON. Right? But what if it's a huge data set? Then it's a huge processing and memory load on the front end, on your actual personal computer. So what we wanted to do was really offload all of that onto our backend server and really just use a UI as a rendering tool that gets JSON and displays it to the screen. So this will also get rid of a lot of overhead and processing and work that the UI team needs to support if teams go to them directly. So we talked about dashboards. Let's create a dashboard. So this is a dashboard builder that our UI team has created, very dynamic. I can now add those 3 views that I have just created, right? So we have that table, we have the graph, and we have that bar chart. We can now save this. And now we have a dashboard that we can view. We have a URL we can pass around through emails, through Teams, and this is all done without the need of a backend developer or even the UI team themselves. So we mentioned some power with Nashorn, but the real power is being able to utilize interfaces from a lot of different data sources. So let's say I have data in Cassandra. So Cassandra is like Redis. It's a NoSQL backend that can basically be used to store cache, globally available. And in our mapping, we have each user, each Netflix user, and properties about themselves. So we have our original query looking at activity over the past 30 days, but that might be too granular. I might want to know, okay, well, let's look at which group has been most active. So what we do is we're able to create a query to get data for each user. We're setting the column family for that Cassandra table. And we're able to, for each result, grab the user and store its manager. So this is JSON that's returned. And we're able to immediately parse that JSON and aggregate now based off the manager. So we create our JavaScript, embed it in JSON. And now we had the same results before, but now it's grouped per manager. So just another way to look at data and to kind of show the capabilities that you may not have thought of before, right? Before we were never storing manager along with the test result. Well, now we can dynamically retrieve that data and merge it together. All right, last example. So we are Netflix Test Studio. We store a bunch of tests that can be run all over the world. We already store external IP addresses from where the test was ran. So what's to say, what can I do with that data? I know of a public geolocation REST API out there, and I want to look at, break down my test results, in this case by city. So again, this is our test development stack. So a lot of tests are run locally, but let's break down by city, right? Let's call this REST endpoint, get that data back, merge it with our own test results, and get a clearer picture about, exactly where tests are being run. So again, have my JavaScript, embed it in JSON, hit my endpoint. Now I get a nice breakdown per city. So what has Nashorn allowed us to do? It's allowed us to create a lot of dynamic engines. It's allowed us to think of solving problems in a different way. But more importantly, it's let teams be able to have control of what they want to see and it's let backend developers have full freedom into doing the projects they have to do.